Okay, welcome back to Algebra 1 Honors. Today we're looking at section 7-8, work problems. And these are the problems that are devilishly difficult for many people to do. You'll see them in a lot of puzzle books, and they're usually funny. There are things like 7 moles can dig 7 holes in 7 days. How long does it take 10 moles to dig 8 holes? You know, they're weird, funny things like that. They're not really all that hard if you just stop and break them apart piece by piece. And this is a problem where a table to organize your information is very helpful. Do not try to do these kind of problems in your head. I don't care how smart you are. Organize your information, okay? All right, first we read the problem. Remember step number 1? We read it and read it and read it. So it says, if it takes Sally 15 minutes to pick apples from her tree, and Lisa can pick them in 25 minutes, how long will it take them working together? Well, just sort of intuitively, okay, first we should write down what it is they want to know. Well, we have to find out how many minutes working together does it take them to do the job. Okay, so that's what we're looking for. And intuitively, if Sally can pick them in 15 minutes and Lisa helps her, adds to her assistance, it's got to take less for Sally's to pick the apples, right? 15 minutes. Now, I suppose there could be a weird situation where, you know, somebody was counterproductive and really slowing you down, but there aren't any of those kind of problems in your book, okay? So we would expect our answer to be less than 15 minutes here, just kind of as a guesstimate, okay? All right, there are a couple things that are odd about work problems. First of all, are how you write a rate, a speed at which someone does a job. You take the amount of time it takes for them to complete the job, and you write the reciprocal, essentially, or of that. You put, so Sally's rate is going to be 1 over 15. The other thing we want to check is to make sure all of our units are in the same dimension. So 15 minutes for Sally, 25 minutes for Lisa. If they gave you 1 in terms of part of an hour and 1 in minutes, you want to convert everything to minutes or everything to hours. Okay? And Lisa's rate is going to be 1 over 25. So that's a little quirky. Okay? It's not 15 and 25. It's 1 over the completion time for each person. Just something you need to remember. Okay, time. They're going to work together, so they're going to work the same amount of time. That's what we're trying to find. Since it's time, I'm going to use T. And I make my T a little curly so I can tell it from a plus sign. Okay? Now, the part of one whole job, this is the other quirky thing about work problems. The first thing is that you put the rate as 1 over the amount of time it takes somebody to do something. The second thing is that you're going to have a fraction that adds up to 1. An equation, I'm sorry, where we add 2 things together to get 1, because it's 1 complete job that they're doing. They use a 1 to stand for the complete job. Okay? So the amount or the part, half or a fourth of the job or a tenth of the job or whatever part of the job that Sally does is going to go here, and whatever part of the job that Lisa does is going to go here. So if Sally does 3/4 of it and Lisa does 1/4 of the picking, then that's 3/4 and 1/4 is 1 whole job done. Right? And the way we find what goes here is just like in our distance problems, we multiply. A lot of our tables are going to be this times this equals this. So we take 1/15 times T, that'll give us T over 15. 1/25 times T, T over 25. Now, this is the part of the job that Sally did. This is the part of the job that Lisa did. When we add those 2 things together, so many 15ths plus so many 25ths, this work has to equal 1 whole job. Okay? So we add them together. Let's see, our common denominator between 15 and 25. 15 is going to be 3 times 5. 25 is going to be 5 times 5. So our least common denominator is going to have 1 3 and 2 5s. Well, let's see. 5 times 5 is 25. 3 times 25 is 75. So that's my least common denominator, 75. So I'm going to multiply everything by 75. Don't forget that side. 75, 15 goes into 75, 5 times it into 15 once. 25 goes into 75 3 times and into itself once. So now I have 5t plus 3t equals 75, not 1. Okay? Add them together, you get 8t equals 75. Divide both sides by 8. And you get t is equal to, let's see, 9 and 3/8 minutes. And that's less than 15. So indeed, even though Lisa picked pretty slow, she helped a little bit. And it didn't take Sally 15 minutes. Together it only took them 9 minutes, 9 and 3/8, almost, not even quite 10 minutes. A little bit less than 9 and a half. Okay? All right.